Welcome to the class. This class is for all CSIR aspirants. Today, dear students and dear my friends, today I am going to discuss a very important topic that is very important for CSIR examination and other competitive examination like JEST, TIFR, BARC examination. So all competitive examination. Now today's topic is, so I want to discuss with you about the polarization of light. Okay, so frequently one question in every frequently after 6 months you will get one question in for 3.5 marks or 5 marks. So very easy question, very tricky question. Within 1 or 2 minutes you will have the correct option, but for that you have to know the concept first, and then after knowing the concept you can easily solve the problems. You see, whenever you are starting somewhere, it means the concept related to that problem is not clear to you. So let us not elaborately, not from zero. I am not going to start from zero, but at least since you know that the polarization of light or the polarization of electromagnetic wave, so just keeping those concepts in mind, so I want to approach further for the application in polarization of light. Okay, so let us move directly to the topic. That topic is polarization of light. Polarization of light, or since light is an electromagnetic wave, so I can say that polarization of electromagnetic wave, EM wave. Clear? So now the heading is, you can write down sometime whenever you feel that I am very fast, you can pause it and write it down. That polarization of light or electromagnetic wave. First, what do you mean by polarization? Polarization का मतलब क्या है? Now see, polarization means confined in a confinement. Okay, if a light, if you confine in a particular direction, that means you are polarizing the light. Okay, sometime suppose you can go anywhere, so your horizon will be very large, but you cannot, suppose someone is restricting you, someone is confining you, that you cannot go in this direction or you cannot go in this direction, or only you can go only in a particular direction. That means that is called polarization. Polarization means confinement. So if you confined the light in a particular direction, it means it is a polarized light. Otherwise, if light go in a light, suppose is spreading in any direction, so that type of light is called unpolarized light. So from the ordinary light, so from the bulb or from the candle, you can say that light is spreading spherically in all direction. So that is an unpolarized light. But you can polarize that light with a particular device called polarizer. Different types of methods are there. So I am not going to discuss about the polarizer and different types, but what is actually polarization and what type of polarization occurs in light, so that we will discuss, and directly we will move to the problem. Okay, now see, first we have to note that the ordinary light is an unpolarized light. It means, you see, I can define it that light comes, and if electric field, why I am saying it is electric field, because light is an electromagnetic wave, so both electric field and magnetic field will be there, and both are in electromagnetic wave, both electric field and magnetic field will be perpendicular to each other. Okay, so that if I take the electric field component, so if I say that light come and if the electric field is not confined in a particular direction, then it is called unpolarized light. Sometime I can write Z or S. Okay, so unpolarized light, it means from a bulb. So if it is a bulb, so light is spreading like this, clear? So in all direction, no confinement will be there. So this is an unpolarized light. Spherically it will spread in all directions. So this is an unpolarized light. Now, so we have got the idea that whenever we discuss the polarization of light, here we'll discuss the electric field, so corresponding to that EM wave or light wave. Clear? Now see, now what type of light we can polarize? Since we are discussing here about the wave, that is electromagnetic wave. Now see, electromagnetic wave or light wave, see what type of light we can polarize, to what type of wave we can polarize. To wave, you see, you in ASS exam, ASS standard, you got the number one called longitudinal wave, you know. The second is transverse wave. Just I am recalling this longitudinal and transverse wave. Now longitudinal wave means what? The particle of the medium will oscillate along the same direction of the propagation of the wave. That means already it is confined in only one direction, only one particular direction. So you can say that no need to polarize the longitudinal wave. Okay, already in one direction it is going, and the particle of the medium is oscillating or vibrating along the same direction of the propagation of the wave. Clear? So we can say that in longitudinal wave no polarization, no need to polarize. But in transverse wave, what happen? That particle of the medium will oscillate perpendicular to the propagation of the wave. Is it? So if I say that in x direction the wave is propagating along x direction, and that suppose this is y direction, this is z direction, that particle of the medium will oscillate perpendicular to this direction. It can move either in y direction xy plane or either in zx plane or in between any plane. So here the particle vibration will be, orientation of the oscillation will be different. Many orientations are possible. Clear? But in what happen? In longitudinal wave only one orientation is possible. So no need to polarize the longitudinal wave. But in transverse wave the particle oscillation can be in y direction or z direction or any other direction between this yz plane. So that is transverse wave. That means just we have to think that it should be perpendicular to the propagation of the wave. Clear? So here we can polarize that light. So I can say that in transverse wave polarization, there will be polarization. Clear? Just I am recalling. And our light wave or electromagnetic wave, this is a transverse wave. Clear? Which does not need any medium. In longitudinal wave we need medium to propagate the wave, but in transverse wave we don't need any medium in any particular medium. I mean, in vacuum also light can propagate, in air medium also light can propagate, in glass medium also light can propagate. Clear? So but longitudinal wave, in case of longitudinal wave we need medium. In vacuum a longitudinal wave like sound wave cannot propagate. Clear? But our discussion say polarization of light, just I am recalling these two parameters. You see, When unpolarized light, if we confine the electric field in a particular direction, so in an unpolarized light, that light we will say is a polarized light. Now what type of polarizations are there? Already you know that there are three types of polarization of light. Number one, so you heard that plane polarized light, clear. Number two, circularly polarized light. Number three, elliptically polarized light. So this plane polarized light and circularly polarized light and elliptically polarized light, these are different. That means here the orientation will be different, here the orientation will be different, here the orientation will be different. Now why it is called plane polarized, circularly polarized and elliptical polarized, we will discuss it later. Now let us take one by one. What is plane polarized light? Clear? Plane polarized light, because in your examination only it will given you that the electric field will be given, and from that you have to determine, you have to recognize that which type of polarizations are occurring on that particular resultant wave. Clear? So for plane polarized light, what happens? So if I can define the plane polarized light as that if the electric field of an EM wave, I will say this is EM wave, if the electric field of the EM wave is confined in a particular direction, then it is called as plane polarized light. It means the electric field will be confined in a particular direction of that corresponding EM wave. So graphically, if we see that, suppose our wave, electromagnetic EM wave, is propagating along this, and this is suppose x axis and this is suppose y axis. Sometimes I can say this is in I cap, that means unit vector along x axis, and sometimes I can say this is j cap, unit vector along y axis. Now the wave is propagating along x axis, okay, and so if I denote that electromagnetic wave, how can we denote, how can we mention that electromagnetic wave? That is, suppose I can say, since EM wave is a vector quantity and electric field equation of that EM wave, so if I write, it will be like this: E equal to E naught, a maximum value, and e raised to the power iota, suppose kx plus omega t or minus suppose omega t. Clear? See that electric field is a vector quantity. Now E naught is a magnitude, this is also magnitude, but a vector quantity and a scalar quantity can never equal. So if I say, if I give here a unit vector, that will give you that vector of this the direction of this vector. So I can say here j cap, or I can write y direction or y cap, or better it will I can say that j cap. See, now this is a vector quantity, now this is magnitude, this is unit vector, so this is whole quantity is a vector quantity. Now see, always remember that whenever you mention that k here, k means the wave vector, and whenever you see any x here, or sometimes you can see that y, kx, ky, or kz, it means the wave vector k, wave vector denote the propagation that means vector of the wave. Okay, not whenever you see x, it means the wave is propagating along x-axis. Here I have drawn that wave is propagating along x-axis, so that is why kx and positive x-axis. Clear? Now, and this j cap, that means this whole magnitude, and this electric field j cap will denote the direction of the electric field, and the electric field is along j cap, along this axis. See that the wave is propagating along x-axis, and the electric field of this wave, it is along j-axis. Clear? So see that electric field is confined along what direction? Y direction or along j cap direction. So this is a plane polarized light. Clear? So it is confined in a particular direction. You got my point? Now you see that it will be called as a plane polarized light, because it is directed, or it is polarized in a particular, confined in a particular direction. Now you got the idea of plane polarized light. Now what will be the circularly polarized light, or what will be the elliptically polarized light? So second our option is circularly polarized light. See, the same definition I can say, if the electric field of the EM wave traces a circle, then the resultant wave is called circularly polarized light. Circularly polarized light. Clear? So another thing I want to mention here, that if I add something, that when light comes and if the electric field, so please add this line here, that when light comes and if the electric field of the EM wave or light, I can say EM wave or light traces a circle, when light comes, or you can say that light comes towards us, then it will be very better for understanding. See, when light comes towards us and if the electric field of that EM wave or light traces a circle, then the resultant wave is called circularly polarized light. You got the line? See, suppose I am a observer, or an observer is suppose observing. Now light is suppose coming towards this observer, and the electric field of that EM wave or light is tracing a circle like this, tracing a circle and approaching towards the observer. Clear? It means, just you see that suppose the electric field is propagating along you, okay, towards you suppose, and if the electric that means light is propagating towards you, or electromagnetic wave is propagating towards you, and if the electric field of that light or EM wave is suppose tracing a circle like this, tracing a circle and propagating along or towards you. Clear? Then it is called a circular, then the resultant light will be called as a circularly polarized light. You got the idea how? Just you see that towards you an electromagnetic wave or light is propagating, and the electric field is tracing a circle, then it is called a circularly polarized. Now how how the electric field will trace will trace out a circle? It there are two possibilities. Either it will be a clockwise tracing, or either it will be anti-clockwise tracing. But here you will say that left hand tracing, that means circle, the trace will be the circle will be in a what you can say, that clockwise means right handed, and anti-clockwise means I will say that left handed. So the circle can be traced out along in using the left hand also and using the right hand. So later when we discuss the problem, it will be clear to you. Now for this time, that remember that. So the clockwise tracing and anti-clockwise tracing. You got my point? Similar thing for elliptically polarized light. Number third, elliptically. So the same definition, when light comes towards and the electric field of that EM wave trace an ellipse, then the resultant light is called elliptically polarized light. It means, suppose the electromagnetic wave is propagating along this towards this observer, and it is tracing an ellipse, Clear? Ellipse means like egg. So if the electromagnetic wave is propagating along you, or suppose coming towards you, and it is tracing, the electric field is tracing out an ellipse like this, and propagating towards you, then you will say that it is an elliptical, the resultant light will be an elliptically polarized light. You got my idea? This is a very simple. Again, here for tracing out the ellipse, you can say that clockwise direction you can draw the ellipse, or anti-clockwise. Here you will use the left hand elliptical and right hand elliptical. So later you will get to know that why I am saying that it is left hand, because sometime in option you will get left-handed circularly polarized light, or left-handed elliptically polarized light, or sometimes right-handed elliptically polarized light. What does it mean actually? Okay, so that will be very understandable in the problem section. Clear? Now see, we got the idea that till now, that what is called plane polarized light, when it is called circularly polarized light, when it is called elliptically polarized light. Now how can we determine that as those all three types of polarized light? There should be some laws, there should be some rules, because using the polarizer we can say very easily, but if the electric field component is given, and you have to recognize whether it is circularly or elliptically or plane polarized light, there must be some rule. That for those rule, first we have to know that the superposition of EM wave, because if only one electric field component is given, then directly you can say, जैसे कि हमने कहा था प्लेन पोलराइज्ड लाइट में E equal to E naught e to the power iota kx minus omega t along j direction, that is a plane polarized light, directly we can say. But in case of suppose two components of electric fields are given, then the resultant light, for resultant you can just recognize the polarizability, you can recognize the type of polarizability only for the resultant light. For that, to find out the resultant light, you have to take the help of the superposition principle. So superposition of EM wave already you know, but you see directly I am writing here the rules, some rules. These rules are very very important, so always try to understand these rules. After getting this rule, it will be very easy for us to recognize the type of polarization. Number one, first we will say that check the state of polarization. Clear? Now state of polarization means, because only electric field will be given, is not it? Electric field will be given, and that is suppose E naught e raised to the power iota kx minus omega t, suppose, and it is jk. State of polarization means that the direction of that electric field, इस इलेक्ट्रिक फील्ड का डायरेक्शन किस डायरेक्शन में है, इट इज along j direction, that is the state of polarization. That means the orientation of that electric field किस डायरेक्शन में, that is called state of polarization. Clear? Sometime it will be given as E1 because two component of electric field will be given. So E2 will be suppose E01, and here I am writing E01 and E02 and e raised to the power iota kx plus omega t, and that is suppose along I direction. You see that state of polarization of this vector and state of polarization, that means the direction of that electric field and direction of this electric field components are different. This is along j direction j cap, and this is along I cap. So these are different. So for that you have to first check the state of polarization, that means the direction of the electric field. So after getting the direction of the electric field, if I say that if the state of polarization for both the electric field, for both the electric field are same, मतलब अगर state of polarity, if the direction of E1 and E2 are same, it is along J and it is along suppose J direction, suppose, then the resultant light will be linearly polarized लाइट. क्लियर? अगर भाई देखो दो वेक्टर एक ही डायरेक्शन में है तो इसका रिजल्टेंट क्या होगा, E इक्वल टू E1 प्लस E2. तो ये लीनियर कॉम्बिनेशन होता है ना कि एक ही डायरेक्शन में होगा, क्योंकि ये भी और ये सेम डायरेक्शन में, तो डायरेक्टली E1 प्लस E2, तो इट इज अ लीनियर कॉम्बिनेशन. दैट इज व्हाई इट इज कॉल्ड अ लीनियरली पोलराइज्ड लाइट, अगर स्टेट ऑफ पोलराइजेशंस आर सेम. क्लियर? नंबर फर्स्ट पॉइंट. सेकेंड, that if the state of polarization are perpendicular to each other, state of polarization किसका है, E1 and E2 का. If the state of polarization of that electric field component are perpendicular to each other, अगर ये एक J direction में है, so for perpendicular, for make it perpendicular, I have to say it is along I cap or k cap. Clear? So if it is perpendicular to each other, then we directly cannot say it is a particular type of polarization. Then another step you have to do, that is called then check the phase difference. Now check the phase difference means check the, for चेकिंग द फेज डिफरेंस, अगर ये और ये z डायरेक्शन में, ये और I डायरेक्शन में है, ठीक है, तो इट इज परपेंडिकुलर टू ईच अदर, देन यू विल चेक द फेज डिफरेंस फॉर बोथ द in between electric field component, that means E1 and E2, ठीक है. So you see, under this condition, if the phase difference, so I'll denote it as a phi, and if it is suppose 0 degree, you know, then pi, then suppose 2 pi, then 3 pi, then 4 pi, dot 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 etc. If it is the phase is suppose 0 pi, 2 pi, 3 pi, up to n pi, dot 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 etc. Then the resultant light is called plane polarized light. Polarized light. Clear? That means अगर इन दोनों का भीतर फेज डिफरेंस, if phi we are getting suppose you know 0 pi 2 pi 3 pi, तो क्या होगा, इनका जो लिनियर कॉम्बिनेशन ही होगा, एक दोनों एक ही डायरेक्शन में. अगर इनका इन दोनों का अंतर, if the phi is 0, if phi is 0 or phi is suppose pi or 2 pi 3 pi 4 pi like this, then directly you can say that a resultant will be you know E1 plus E2, ठीक है. अगर 0 है तो एक ही डायरेक्शन में होगा, अगर सपोज पाई है देन इट विल कम, अगर एक इस डायरेक्शन में और एक इस डायरेक्शन में तो निगेटिव आ जाएगा, लेकिन उनका निगेटिव का जो एक पर्टिकुलर इसका एक ही डायरेक्शन में होगा. सो इट विल बी लाइक when we discuss the plane polarized light, that means only one direction will be directly, that means transcendental direction, linear direction, ठीक है. So in this case, if we are getting 0 pi or 2 pi 3 pi 4 pi, then the resultant light will say it is a plane polarized light. Clear? Now if phi or phase difference we are getting suppose pi by 2, clear, and suppose 3 pi by 2, I am not taking 2 pi by 2 because 2 pi by 2 will be pi, so already we have taken, and 5 pi by 2, you know 7 pi by 2, dot 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 dot. Clear? If it is pi by 2, 3 pi by 2, 5 pi, I am not taking 4 pi by 2 because 4 pi by 2 will be 2 pi, so it is already taken. Clear? So and 7 pi by 2, then 9 pi by 2. If the phase difference is like this, then we directly cannot say that which type of polarization. You see, when we are getting this phase is like this, directly we will say plane polarized light, then no need to check the further procedure, no need to go for further procedure. But if you are not getting like this, and if you are getting the phase differences like this, then we'll check the maximum amplitude. The amplitude, इसका amplitude का मतलब क्या होगा, ये जो क्वांटिटी है E01 एंड E02, तो इसका तो एम्पलीट्यूड है इलेक्ट्रोमैग्नेटिक इस इलेक्ट्रिक फील्ड का. तो then if phase difference is like this, then if you know E01 मैग्नीट्यूड लेंगे, if and E02 अगर ये दोनों इक्वल है, बराबर है, if this are same, these two quantities are same, then the resultant light is called circularly polarized light. Circularly polarized light. Are you getting my point? Why it is circularly polarized light? See, इसका जब हम मैग्नीट्यूड लेंगे, तो इसका अगर मैग्नीट्यूड ये दोनों क्वांटिटी अगर बराबर होगा, अगर ये दोनों क्वांटिटी इफ दीज आर सेम, दैट मीन्स ऑल्दो directions are perpendicular to each other, एक इस डायरेक्शन में है और एक इस डायरेक्शन में है, बट दोनों का मैग्नीट्यूड क्या है, सेम है, तो अगर ये क्या बनेगा, so the magnitude, the maximum amplitude will give rise to the radius of that circle. तो यहाँ पे क्या होगा, जब ये दोनों इक्वल होगा, then we will say it is an circularly polarized light. Clear? ठीक है? And see second point, another next point, if that E01 is not equal to suppose E02, then the resultant light is called elliptically polarized light. Elliptically polarized light. You got my idea? अगर ये दोनों सेम नहीं है, अगर इलिप्स का क्या होता है, it is just like this, so this radius and this radius are not same. अगर ये और ये रेडियस सेम होगा तो वो क्या होगा, a circle बनेगा. But an ellipse, this is and this distance and this distance are not same. It means E0 and E01 and E02, this magnitude and this magnitude, if it is not same, then it will be called as an elliptically polarized light. You got my idea? ठीक है? तो see, when we'll say ये प्रोसीड्यूर हम कब फॉलो करेंगे, when the state of polarization is perpendicular to each other, then we will check phase difference. If the phase difference is like this, directly we will say plane polarized light. And if you are getting the phase difference is like this, then directly we will say that we will for next step, if E01 and E02 are same, then it is, we will call it as a circularly polarized light. If these two quantities are not same, then we will call it as an elliptically polarized light. Now you got my idea? Now see, क्या फेज डिफरेंस ये वैल्यू और ये वैल्यू हो सकता है, और तो कुछ भी वैल्यू हो सकता है. सपोज पाई बाई फोर आई एम नॉट टेकिंग हियर, और 3 पाई बाई 4 और 5 पाई बाई 4, दोज वैल्यूज आर ऑल्सो पॉसिबल फॉर फेज डिफरेंस. नाउ सी, इफ लास्ट पॉइंट इज if phi is other than 0, pi by 2, pi, 3 pi by 2, 2 pi, that means जो भी पहले हमें मिल चुके हैं, that means 0 we took, pi we took, 2 pi, 3 pi, then pi by 2, 3 pi by 2, 5 pi by 2, other than these values, like क्या क्या हो सकता है कि pi by 4 हो सकता है, pi by 6 हो सकता है. So I am not taking all these values because there are many possible values. So just I am writing that if phi is other than these values, then directly we will say the resultant light, is called elliptically polarized light. Elliptically polarized light. In this situation we don't need to check the maximum magnitude. मैग्नीट्यूड चेक करने की जरूरत नहीं है, डायरेक्टली विल से elliptically polarized light, और कुछ भी चेक करने के लिए हमारा जरूरत नहीं है. Now these are the rules. Keeping this all rules in mind, so we'll move to the problem solving part. You got my idea? Now if I summarize these all rules, so in a very easiest way, तो पहले हम क्या करेंगे, जो भी इलेक्ट्रिक फील्ड गिवन होगा, फर्स्ट we will check the direction of that for both the component. If it is same direction में है गया, तो हम क्या बोलेंगे उसको, that is linearly polarized light. If the state of polarization, that means the direction for both the electric field components are perpendicular to each other, then we'll check the phase difference, and if the phase difference we are getting suppose 0 pi, 2 pi, 3 pi, 4 pi, then we will say that plane polarized light. And if the phase difference is pi by 2, 3 pi by 2, 5 pi by 2, or 7 pi by 2, then we will check their maximum magnitude or amplitude. Then if the amplitudes are same or magnitudes are same, then you will say that circularly polarized light. And if the amplitudes are not same, then you will say elliptical polarized light. Or if the phase difference phi is other than or those all previous values like 0 pi, pi by 2, 3 2 pi by 2 pi, 3 pi by 2, इनके अलावा जितने phi value होगा, for all those values, directly we will say the resultant light will be an elliptically polarized light. ठीक है, तो ये सारे बात हमारे समझ में आ गया. नाउ नेक्स्ट वीडियो में हम क्या करेंगे, इसके ऊपर हम प्रॉब्लम सॉल्व करेंगे. सो प्रॉब्लम्स आर वेरी इजी. So I hope you got the idea how can we recognize the type of polarization and why do we need this chapter, why do we need this topic. Because I earlier that at the beginning I mentioned that one question every time you will get one question for 3.5 marks or 5 marks. Clear? And very easy, within 1 minute or 2 minutes you can have the correct option. So in problem solving part you will get to know that why it is important, why we should discuss on this topic. So thank you.